Hello friends, welcome to PansimTech Private Limited. So in our last video, we saw two different types of governing equations. That is your continuity equations and momentum equation. In this video, we are going to see the, um, the basically governing equations related to energy governing equations. Okay, let's move ahead. So what is exactly is energy equation? So from the first law, as we know that rate of change of energy is what? Net flux of heat into the element plus work done on the element. Okay, and work done can be of because of two forces, surface forces and body forces. Okay. In our previous video also we saw how what is the rate of work, what is the force, what is the body force generally put acting on it. So volume into density. So F is the function of volume into density. Okay. So this is our body force. And so net rate of work done on the fluid element is what? Net rate of fluid done by pressure force in x. So basically we are seeing in x direction. So in x direction, pressure change in x direction. So mm, pressure force in plus shear stress force in x direction. So how to get calculation of this pressure force, etc., that we already saw in our last video. So if you want to see the detail, okay, what is the phase element, how it is going in this direction, how to take care of this pressure force. So right, see what is dy into dz. Dy dz is the area of this phase element along this direction, and how we are in terms of partial differential equation, change in velocity with in x direction into dou x. So this all discussion we already did in our previous video. Okay, so I'm not again repeating here, please check it from there. Okay, so pressure force plus shear stress force, so work done by the different force, surface force. So body force plus surface force. Next, so what is net rate of work done by pressure force in x direction? So as we saw that pressure into velocity is what? Work done, correct? Newton per meter square into meter per second. What is the unit? Joule per second, that is what? Right? So please take care of the units also. And if we are multiplying this with area, that means meter. So you can see meter per second, just wait, try to understand. So meter per second into Newton by, what is force? Force per unit area, pressure, into again meter square, because area is the unit of area is what? Meter square. So this cancel. What will Newton meter per second? What is this Newton meter? This is nothing but joule. So joule per second is what? It is power. Can we say this is power? That means hopefully you understand. So and you can say from the unit also, what is the work? Force into displacement. Force into displacement. So work done by time is your power. Okay, don't confuse. So net rate of work done in by shear stress in x direction, same calculation using the partial differential equation. Okay, change in final velocity, initial minus final into area. Similarly, initial minus final into area. So this is the term in individual you will get. So this is for pressure force, this is for shear stress force. And so what is the net work done? You can sum up this all along with body. What is the volumetric heating? That means body force. So net heat transfer due to conduction in x direction is this. If you so over, you can say this is the thing after this all calculation. So heat transfer due to conduction in all direction is this. From 4 years law, we know that this is the 4 years law. So this that in terms of temperature, if you want to substitute this value, just substitute in terms of temperature. So you'll get this type of equation. So this equation generally we are discretizing it and hooking this all discretized equation in our current software. Okay, hopefully it's clear. Now summary of governing equations. The most important, whatever we did till our last video. So this is a summary of all. So this is continuity equation in non-conservative form. in conjunction. You can visit our last video. That is very important. If any person is seeing this video without checking that video, they will not able to understand what is the continuity equations, how we are deriving this continue. All the derivation we already mentioned in that. Similarly, momentum, this all three equation we described in detail in our last video. Similarly, for how we are getting Navier-Stokes equation from the momentum equation already covered in our last video. Okay, energy equations is covered in this video. Euler equations from inviscid flow. So this is nothing but you can say just ignore the viscosity in our energy equation, momentum equation, and continuity equation. You will get this type of equation. Okay, try to substitute from your side. Okay, so Bernoulli equations. So there are some limitations of Bernoulli. Do you know the limitations of Bernoulli equation? You can't use external force. That is the exception of the Bernoulli equations. So if you are applying any Bernoulli equations, you can't use external force within the Bernoulli equations. Okay, this is exception. You can. This is the fluid mechanics thing. So I'm not going in detail into that. You can check it from your own. So what is irrotational flow? The particle. Suppose what is rotational flow in compressor? So when dou rho by dou t or dou whatever change in density is 0, incompressible. If it is not equal to 0, it is compressible. Okay. If viscosity is negligible, inviscid flow, like ideal fluid. And steady state means if the things parameter is not changing with respect to time, that means that is equal to steady state. Okay. Hopefully, I think it's clear now. So this is the something little bit about our company. We are doing lots of things like you can take our training, etc. for better understanding. Okay, so this is our company. We are doing engineering consulting projects. We are also doing we are expertise in CFD, and basically you can say any type of guideline, any type of things. Even you can contact us, and you can check our you can visit our website for detail. Okay, thank you very much. Thank you for your time. Have a good day.